Hello everyone, welcome to the World Indicator System demonstration video. In this video, I'm going to talk about a few things, so feel free to jump to the section that's most relevant for you. We're going to start from an introduction, explain what the World Indicator System is, talk about the key advantages, and a general overview. From there, we're going to fire up the Unreal Engine editor. We're going to open up the single player example level. We're going to go in depth into each example in this section. Then we're going to open up the split screen example level, and finally the online multiplayer example. The split screen example and the multiplayer example are based off the single player example. Therefore, the most in-depth explanations are going to be found in this section of the single player example. Let's start with the introduction. World Indicator System is an Unreal Engine 5 plugin for adding on-screen and off-screen indicator, as the name suggests. It works with any user widget and supports both split screen and online multiplayer, meaning you can use any user widget in your project and it's going to work out of the box. World Indicator System aims to be the all-in-one screen indicator solution for any Unreal Engine 5 project, regardless of the widget setup or the UI setup of the project. Whether it's a single-player experience, an online multiplayer game, or a local co-op title. Key advantages of the World Indicator System. As mentioned before, it works with any user widget. But what if a widget needs to display information such as the distance to the player pawn, or it needs to rotate towards its target? Then the widget can implement the indicator widget interface. Through this interface, the system will notify the widget with useful information such as the distance to the indicator's target and the rotation value. The system supports local split screen by design, because each time we create an indicator, we must specify the player controller. Through the player controller, the indicator will be adjusted to operate in the region of the selected player controller. The system supports online multiplayer out of the box. This is done by the World Indicator Network component. This component needs to be added to the player controller, and then it includes many handy functions for broadcasting, creating indicators, and removing indicators. World Indicator is managed by a world subsystem. Every time we create an indicator, it's saved to this subsystem and managed internally. Whenever an indicator goes out of use, the subsystem will remove it from memory. We're not using actor components, meaning we do not need to add a component to any actor that has an indicator. Instead, we're going to be calling functions on the World Indicator function library and creating indicators regardless of the class of our actors. This makes it really useful for higher level systems such as a quest system or a dialogue system. A quick overview of the structure of the system. From any blueprint that has access to World, we can call functions on the World Indicator function library. The function library will then communicate with the World Indicator subsystem, and the subsystem will internally manage its indicators, including removing the indicators that go out of use. All right, let's dive into the Unreal Engine editor. Let's start from a quick showcase of all the examples in the single player level. First, we have the simple cube. It has an indicator that turns into an arrow that also rotates towards the cube when it's out of bounds. Next, we have this example where the indicators are added to the bone names of this mannequin. Next, we have this example that adds an indicator to the static world location of this smiley face. It's not attached to an actor, but to the static world location. Next, we have this example, which uses a radius to determine when to hide and when to show the indicator. Whenever we're inside the radius, the indicator is shown, and when we're out of the radius, the indicator is hidden. This example is built upon the distance example. Here, we have this radius. When we're outside of it, we see a minimized version of a speech bubble. Whenever we're inside the radius, the speech bubble can expand. It can expand and also be minimized when it goes out of bounds. But when we're outside of the radius, we're forcing the minimized version. Next, we have the line trace example. This example uses a line trace between the camera and the location of the indicator. Whenever the indicator is blocked by an object, it's hidden, and whenever the line trace is clear, the indicator is shown. Settings can be tweaked, such as the player can also block the line trace, or the line trace can also start from the player instead of starting from the camera. This is the example, gameplay example. Here we spawn a cube, add an indicator to the cube, and also add another indicator to this goal. As we can read above, we need to push the cube inside the goal to successfully pass the mission. The cube also has a radius calculation similar to the ones we saw before, except now we remove the indicator when we're close to the cube and we show it when we walk away far enough. This is useful for situations where we want the player to be playing with an objective, but if they walk away from the objective, we can say, hey, your objective is here, come back. The cube went inside the goal and the indicators are removed. This signifies that the mission has been successfully finished. First thing I want to talk about is the World Indicator plugin settings. We can find it under Edit, Project Settings, scrolling all the way down to World Indicator Settings, and there are a few useful tools. Border Scale is the value relative to the size of the current playing viewport. When it's set to 1, it's going to match the size of the viewport. We can display the border scale by setting Draw Debug Border to True. I'm also going to set the thickness to 10 so it's better visible in the video. Create an indicator and we can see that the debug border is on the edges of the viewport because it's set to 1 and it matches the scale. Let's go ahead and change the viewport scale to 0.6. Now we're going to see that the scale of the world indicator system is 60% of the scale of the current viewport. This is useful in cases where the project needs a custom size for the scale of the indicators, or even for user settings where the user might have a display that does not show UI correctly at the edges. The border scale is saved to the game user settings .ini file, which is really useful exactly for this purpose. The second setting we have is the allowed dead zone scale. This is essentially the distance that the indicator must travel outside of the border before it becomes out of bounds. So I increased it from 1 to 1.05, and let's see the results. Now, when the indicator goes outside of the border, it must travel a certain distance before it becomes out of bounds. Let's talk about the core of World Indicator System. As you can see, this cube has a main widget, is this white circle, that transfers to the border widget, which is this white arrow that also rotates towards the cube when the indicator goes out of bounds. So the main widget is shown when the indicator is in bounds, and the border widget is shown when the indicator is out of bounds. To find the indicator information for each example, we can click the button and then in the right-hand panel, open its blueprint. We're going to go over the logic in a moment, but for now, in the Add World Indicator node, we can go to the Data Asset section, click this Browse button, and it will take us to the data asset. Let's open it up to understand it a little bit better. As you can see, the World Indicator data asset is separated into two parts, the main widget and the border widget. The main widget class is necessary for an indicator to be valid, so we must always select a main widget class. The border widget class is optional and will only be used if any widget is selected. Otherwise, only the main widget will be shown. Under the widget specification, we have a pivot value to display the widget, a rotate widget value, which when set to true, a rotation for the widget will be calculated, and a hide delay, which will enable the widget to play animations for the duration of the delay. Let's see how the hide delay and the rotation come into play. In this blueprint, we've got a distance text and this arrow image. I'm going to open up the graph. We can see that there are a few events, and these events come from the world indicator widget interface. To implement the interface, any widget can go to class settings, interfaces, implemented interfaces, click add, and search for world indicator widget interface. After the interface is implemented, we can go to interfaces, and we've got the world indicator events. We have show widget, hide widget, and update. Let's start from show widget. This event is called whenever an indicator's widget is shown. Pretty simple. Then we have the freedom to choose what happens. For this widget, I'm playing an animation called fade. It's this animation here, which looks like this. Okay, the length of the animation is 0.25 seconds. So if I open up the data asset where I'm using this arrow, I set the hide delay to true and the duration for 0.25. This way the hide delay will end exactly when the animation ends. When we call hide indicator, this event is called, and we play the fade animation, except we play it in reverse in this case. Next, the update event. This update event can be used as tick, essentially, and it gets called every frame. We get a few useful variables, such as the target location, meaning the location of the indicator, the widget render angle, which we can use to set the set render transform angle of the widget. In this case, we're using the arrow. So whenever we have a rotating widget, we must make it face downwards. And then if we want to rotate it, we take the render angle value given at the update event, and we set the render transform. Then we have another useful value, the distance to the owning player pawn. This distance can be calculated also by taking the target location, which is the location of the indicator, and getting the distance to the owning player pawn, and then of course get actor location, like so. And this value here is the same value as the indicator distance to owning player pawn. All right, and then here is some logic that's not directly related to world indicator, but I'm going to explain it real quick. I'm taking the delta time and the distance to the player pawn. I have a last distance variable that I use to interpolate values, so the changing of the values looks smoother. Then I divide the distance by 100 to convert it from centimeters to meters. I leave only one fraction digit, format the text, and then I set the text on top of the arrow to be the distance. Let's see this in action. Here we have this example where we have the arrow. This is the main widget. It does not rotate, but it does show the distance to the player pawn. When it goes out of bounds, it becomes the border widget. It does rotate and also show the distance. Again, the data asset has the same widget for the main widget and for the border widget, so that's okay. The difference is that the border widget has rotate enabled and it uses the rotation values. The main widget has rotate set to false, And this means that this value here, when rotate widget is set to false, is always gonna return 0. All right, it's finally time to dive into the blueprint of the example. So just to remind ourselves real quick, the first example, whenever we press the button, an indicator is added. And whenever we click the button a second time, an indicator is removed. To see the blueprint, we're going to open up the editor. We're going to click this button here, not the cube, but the button. We're going to go to the details panel here on the right and open up the blueprint of this button. As we can see, on button pressed, we flip-flop between two states. When it's pressed first, we're going to show an indicator, and a second time, we're going to remove the indicator. Let's go ahead and look at the Add World Indicator node. This is the base node for adding indicators in World Indicator System. This node must take a player controller, a data asset, which is discussed previously, an actor, a component that in this case is the root component owned by the target actor, which is the cube. So we're taking the root component of the cube and we're sending it as the attachment point for the indicator. We're leaving socket name at none, we're not using any sockets, and auto show is set to true. If I set auto show to false, this function will not show the indicator. It's going to be added, it exists in the world, but when I click it, nothing happens. This is intended for cases where we do not want to show the indicator immediately after we add it to a certain object. We can later on take the indicator reference returned by this node, and we can call show indicator whenever we like. There it is. So let's move on to removing the indicator. So since we are storing an indicator reference after calling this function, we can also use the same reference to later on remove it by calling remove from world. This immediately removes the indicator without any animations or stuff like that, and essentially marks it as garbage. We must dereference our stored reference of the indicator if we want the system to be able to remove it from memory. This is very important. Now, the nice thing about World Indicator System is that we actually don't have to save a reference for this indicator. I'm going to go ahead and just delete this reference completely from the blueprint. What I'm going to do is I'm going to show you guys the next removal options. First, we can immediately remove all world indicators that are tracking a certain target. Our target is the blue cube. So we can plug this in here instead, and notice that we're not keeping any references to this indicator. We create it, we auto show it, and then we just remove it at the end here. This makes it easier because then we do not need to dereference anything or remember to clean up any references. The next function we can use is get world indicators by target actor. This function will give us an array of all the indicators attached to this actor right now, to the cube. Then for each one of them, in our case, there's just one indicator, so we might as well call get the first copy, and it's going to work just the same, and we're going to hide and remove it. This function is different from the function remove from world. This function removes the indicator immediately without any hide functions or animations or delays. This one is going to let the hide delay discussed in the data asset play out. So what's going to happen now, pay attention, then when the indicator is removed, it's going to fade out instead of being removed immediately. So it's still alive as long as it's fading out, and then it's removed completely. In this example, we're adding indicators to the bones of this mannequin. Let's dive into the blueprint. Like last time, we're going to click the button and then open up its blueprint from the right-hand panel. We have the event on button pressed, and then we have some logic for selecting bone names for the bone to attach the indicator. This is irrelevant for the world indicator system. When we show an indicator, when we add an indicator, we select one of the bones from the bone names, and then the difference with the other example is that here we're using a socket name. That's essentially the whole difference here. We are taking the interacting player controller, which can also be the player controller at index 0, since it's a single player environment. We have a data asset. This time it uses different widgets than the other example. We're taking the mannequin's skeletal mesh component as the target component. And each time we're using a different socket from the socket name array. We are not keeping a reference for the indicator that's created. Instead, when it's time to remove the indicators, we just take all the indicators that are added to the target actor, which is the mannequin, and then we remove all of them at once. Again, we're going to be adding 5 indicators, 1, 2, 3, 4, 5. And with a single function call to remove, all of them are removed. This can be really useful when we have a situation like this, where a single actor has a few indicators. We can remove indicators by target actor. Next, we have this example where the indicator is added to a static world location instead of being added to an actor. Let's open up the blueprint. As always, we click the button, and on the right-hand panel, we open up the blueprint. Again, similarly to the previous examples, when we click the button first, we're going to add an indicator. When we click it a second time, we're going to remove it. The important thing to note here is that we're adding an indicator without a target actor, meaning we cannot use functions such as remove indicator by target actor. We cannot use remove indicator by target component. We can use remove indicators by player, but then we're going to remove all of the player's indicators. And if the player has other indicators on screen, we might not want to remove all of them. So the solution for this, in this case, is to keep a reference to the indicator and then remove it when we're done with it, and remember to dereference it. Again, we're adding an indicator at location. We have this location variable, which this button has it set to, let's see, was it location? Yeah, location to indicate. Okay, this button is just a variable that I set to be the location of this funny face. Next, we have this example, which uses the world indicator async node system to call events depending on a distance to the player pawn. Here, whenever the pawn is inside the radius, we're going to show the indicator. And whenever the pawn leaves the radius, we're going to hide it. It does not remove the indicator, but keeps it in memory. It only hides it visually. Let's go ahead and check out the blueprint. So as always, we're going to select the button, go to the right-hand panel, and open up its blueprint. Similarly to previous examples, there's something that we do when the button is pressed. We show the indicator, and when the button is pressed a second time, we remove it. Let's start from showing. So first of all, we add an indicator. In this case, we set auto show to false because we do not want to immediately show the indicator. We store a reference for the indicator. Next, we create an async node, wait indicator distance from actor. There are a few versions of this. Wait indicator. There is async distance from actor, async distance from component, or async distance from location. In this version, we're going to use a location to compare. Instead here, we're waiting for a distance from an actor, which is the controlled pawn. So we set up a range of 600, which is the range of the sphere that we see when playing, and we set its draw debug to true. Let's go ahead and set the distance to 200. And notice that also we get complete freedom to choose what happens when the indicator is in range and when it's out of range. In this case, I chose to hide the indicator when it's out of range and show it when it's in range. What we could do is simply switch between them. Let's go ahead and see that it works. So we expect to see a smaller sphere now because I set it to 200. There it is. And when we're outside of the sphere, we're going to see the indicator. But when we're inside the sphere, it's going to be hidden. Exactly the opposite behavior of the example by default. Okay, again, I can switch between them. And now we're going to get the same behavior with a smaller sphere. There it is. Next, we have this example, which is built upon the distance async node. Whenever we're outside of the radius, we force the minimized widget. This is the border widget. We force it. It can never change to the main widget. But when we're inside the radius, we allow it to expand to the main widget, and we still keep the functionality of the indicator, which minimizes it when it's out of bounds. Let's go ahead and open up the blueprint. In this case, we actually click the mannequin and open its blueprint. It's the only example that doesn't have a button for it. Okay, here we have some logic that is unrelated to world indicator. It's meant to make sure that this works both in a multiplayer environment and a single player environment. We begin an overlap with the player pawn. And then we add an indicator to this mannequin. Here, for the example's sake, I decided to set add unique to true. This thing could be dangerous in the sense that the indicator here might be null when add indicator unique is set to true, because this will only create an indicator if this player controller does not have an indicator on this target component, or the actor that owns this target component. Okay. So after adding the indicator, we take its reference. We do not save the reference. We take it immediately, and we create the distance node. Also, we do not set auto show to true. Auto show is set to false because we do not want to immediately show an indicator. We're going to let the node take care of it, the distance node take care of it. Whenever we're in range, we're going to show indicator normally. And whenever we're out of range, which is the first state, we're going to force the border widget. Show indicator is going to reset the settings and make the indicator behave like all the other examples where we have the main widget and we have the border widget. For this example, let's go ahead and instead of calling show indicator, let's go ahead and call force main widget. So instead of, so now when we're out of range, we're going to force the border widget, and when we're in range, we're going to force the main widget. Let's see what happens. So whenever I'm out of range, I'm forcing the minimized widget, the border widget. Whenever I'm in range, I'm going to force the main widget. So no matter what, even if it goes out of bounds, we're going to see the main widget. We step out, border widget. Step in, main widget. Now, an important part is the removal for this example. Because when we remove the indicator in this example, we are using get world indicators by matching player and target. Okay? This function is intended specifically for split screen when we have different player controllers that need to remove the indicator. In this case, the indicator that we're gonna get from this function is the indicator that has both the player controller and the target actor. Okay, the target actor in this case is this mannequin. So it has to have this mannequin and the player controller that is possessing right now. This is a single player example, so maybe it's not as important. But when we go to the split screen example, this is really important. Next, we have the async node line trace example. This example uses a similar technique to the previous example, except instead of distance, we're using a line trace. We have a line trace from the camera to the location of the indicator. And whenever it's blocked, we hide the indicator. And whenever it's clear, we show the indicator. Let's go ahead and check out the blueprint. As always, we select the button and open up its blueprint. And similarly to the previous examples, when we first press the button, we're going to show the indicator. And when we press the button a second time, we're going to remove the indicator. Okay, let's start with showing the indicator. So in this case, I add the indicator to the spine 04 bone of the mannequin. I take the mannequin, cast it to a skeletal mesh actor, take the skeletal mesh from it, and add an indicator to the socket name spine 04, and we do not auto show the indicator. We do not auto show it because we let the wait indicator line trace event handle it for us. So for the line trace, we can add actors to ignore. In this case, it's the target actor, which is the mannequin, and the player pawn. So as I see here, this casting to character is a bit redundant. I don't know why I did it. I think I was using it for something else. We can just take the controlled pawn, and then we choose the channel to trace on. I chose world dynamic because it fits my setup of the project. The line trace is left empty. All of these settings are advanced and hidden by default. When the line trace is empty, it falls back to the first player controller's camera. Okay, so I'm gonna show you guys what happens if I actually change the line trace to start from the controlled player pawn's root component. Okay, draw debug is set to true, and then we have the most important part of the node, which is the events. So whenever the line trace is cleared, we show the indicator, and whenever the line trace is blocked, we hide the indicator. And this is totally free, up to you, total freedom to do whatever you like whenever the line trace is cleared or blocked. Okay, so let's go ahead and check out what happens here. Remember that I changed the trace start to be the root component of the controlled pawn. And let's go ahead and check it out. Now we can see the line trace from the root component, which is the, I don't know how to call it, the the pelvis of the player pawn, and then you guys can see that it works. All right, cool. Now back to the blueprint. Let's see what happens when we remove this indicator, because this is pretty interesting. Here, instead of calling the remove functions, I call the get function instead. So we're getting the world indicators by target actor. Notice that I'm also not storing a reference to the indicator. I'm not saving a reference to it. So I'm just creating an indicator, and then I'm making the async node for it with the line trace. I'm not storing a reference for this indicator in any point. Instead here, what I'm going to do is I'm going to take my target actor, I'm going to get the indicators for this actor, and then I'm going to loop on each. In our case, there's just one, so we can delete this loop, and we can actually just get the first, the indicator at index 0, and we're going to call hide and remove from world. This function, as opposed to remove from world, the difference is that hide and remove from world is going to first call the hide logic on the indicator, letting it play animations and stuff like that, and only then it's going to remove it when it's finished. Remove from world will immediately remove the indicator without any hiding logic. Okay, let's check it out. We'll see that it still works. Whenever I push the button, the line trace starts and the indicator is shown. Whenever I press it a second time, it's blocked. Also, the reason why I don't show it by default is that sometimes when I press the button, the first state is going to be blocked. So we do not want it to show. But if I start when I'm not blocked, we want it to show. Awesome. Last but not least, we've got the gameplay example. When we press the button, we spawn a cube and add an indicator for the cube. We also add an indicator to this goal here. We can press the button again to destroy the cube and remove the indicator from the goal. Let's see it again. Spawning the cube, adding an indicator for the goal, destroying the cube. The cube has an async distance node. When we get close to the cube, we remove the indicator. When we go far from the cube, the indicator is added back. When the indicator is successfully pushed inside the goal, we remove the indicator. Let's go ahead and see the blueprint. So as always, we select the button, open up the blueprint for the button. Now this example is a bit more complex than the other ones. We've got here a lot of logic that's unrelated to world indicator. I'll go over it really quick. On begin play, we bind an event for the goal. Whenever the button is pressed, we either end the mission or we spawn the cube and we start the mission. When the goal begins overlap, we're checking for the cube, and if it's the cube, we call the end mission successfully, and we have a function for spawning the cube. Okay, now the part that is relevant for world indicator. When the mission starts, this function is called after we've spawned the cube. The cube is this variable here, indicator target actor. We add an indicator to it using the add world indicator unique. This node is useful in situations where adding the indicator is caused in gameplay, and we might already have added an indicator in the past. And this node has two output execution pins. When the indicator has been successfully added and this value is valid, or the indicator has not been added and this value is not valid. This node is the exact same functionality as calling the normal add world indicator, setting add unique to true. As we can see here, the auto show is false, so we can turn off auto show, and then taking the indicator and calling is valid on it. Okay, these are equivalent. Once we've added an indicator for the cube, we create a wait distance async node for it. Like we saw before, whenever we're in range, we hide the indicator. Whenever we're out of range, we show the indicator. Let's draw the debug sphere next time we see the example. And after we add an indicator for the cube, we move on to adding an indicator for the goal. The goal also has a function that is called on the indicator to set the render opacity to 0.5, making the indicator just a little bit transparent. So let's see it again. Here's the cube, it's spawned. Whenever we are inside the radius, we remove the indicator, out we add it. And when we push the indicator into the goal, both of the indicators are removed. Now, the interesting thing about it is that since the world indicator subsystem is managing the indicators for us, then when we click the button to end the mission and we destroy the indicator, we destroy the cube, here it is, we don't need to take care of the indicator. The world indicator subsystem internally manages this. When an actor that's being tracked by an indicator is destroyed, the indicator is taken care of alongside the actor. All right, so again, whenever we end the mission, we remove the indicator from the goal and we destroy the cube. We also dereference the cube. Whenever the mission ends with success, we take both the goal trigger and the cube and we call the same functions on them. We take their indicators and we call hide and remove, so we can get a little bit of a hide animation before the indicators are removed. Let's move on to the split screen example. To access the split screen example, we're going to open up our content browser, go to plugins folder, world indicator system, world indicator, split screen example, and then maps. I'm going to open the level indicator split screen lobby because this level allows me to choose how many players I'd like to start with. So I'm going to go ahead and choose 2, click start, and the example level opens up with 2 players. What I'm going to do is I'm going to start with a quick showcase of the level. The examples are the exact same as the single player level, except now they work for 2 player controllers. So we've got the same cube, except now it has one indicator on the right hand side of the screen and another indicator on the left hand side of the screen. Okay, all examples except this one here, they add an indicator to both of the players, meaning once this mannequin has an indicator, both of the players see it. Okay, except this example where now the player on the right sees it, but the player on the left does not. This example is interacted per player basis. Okay, and now also the player on the left sees it. So this example is really nice for a split screen situation. We're going to go into the blueprint just a little bit later. Here we've got the example where the indicator is at a static world location. And then we've got the distance example. We have a bit of a problem with the debug, but the functionality works just the same. So it's just a matter of the debug sphere. Let's go and see the world indicator line trace example. Now, the interesting thing about the line trace example is that, as you can see, the line trace, it goes to the camera of the other player. So the camera is located here. Okay, that's the position of the camera of the second player, the line that we see on the screen. And each screen gets the async node is working per indicator, per screen. Okay, and finally the gameplay example. Both players can see now the cube and the goal. If you watch the previous examples, whenever the player gets close to the cube, the indicator is removed. As we can see, it's going to be removed only for the player that came close to it. The other player still sees the indicator, because the indicator instances are separate. Each one of the players has an indicator for itself. There it is. Now it's time to go over the blueprints. The first example in the split screen map. Let's go ahead, select the button, open up its blueprint. Now the example is the exact same as the single player example. So if you'd like a more in-depth explanation, go ahead and look for it in the example section, in the single player section. The only difference here is that I have a function called getLocalPlayerControllers that I wrote. All it does is it gets the number of player controllers and then just organizes each controller into an array and returns it for me. When I have all the local player controllers, I loop over them, and for each one, I'm adding an indicator just the same as the single player example. When the button is pressed a second time, that's maybe the interesting part, is that I can call remove indicators by target, and I'm going to remove them for all players. Okay, this does not filter by player. Whenever this function is called, all indicators for a target actor will be removed. So this could be both convenient and inconvenient for a split screen environment. Let's head over to the next example to see how this thing can be overcome in a split screen environment. So in this example here, with this mannequin, we're going to go ahead and open it. And this example is more tailored for a split screen environment. This example is the same across all levels. It's the same blueprint. We add an indicator. We create the the weight indicator distance from actor event. Whenever the actor is in range, we either in the original version, we show indicator instead. And when it's out of range, we force the border widget. All right, I'm going to show it real quick, even though this is just one player, still just to show the idea. Whenever we're outside of the radius, we force the border widget. When we're inside, we can show either the main widget or the border widget. All right, now for removing indicators on a per player basis. Here, when we remove the indicator, we use the get world indicators by matching player and target. So in this case, we're gonna give a player controller and the target actor, and it will remove indicators that match between both the player and the target actor. So this function is the getter, but we have the same version for remove. So we can remove world indicators by matching player and target actor. I'm going to show you that this works just the same. We're going to go ahead, create them, and when we walk out, it's going to remove them. The difference here is, again, I've mentioned this previously, is that we are using the getter so that for each element, we can call the hide and remove function. This will allow the widgets to do a hide animation. Let's take a look at the async distance node example for split screen. As always, we select the button, open up its blueprint, and the same as I mentioned, the example is the exact same as the single player, except now we're going to be adding indicators for all player controllers. We're going to loop over all the player controllers. We're gonna, for each player controller, we're going to add an indicator. We're gonna skip showing it. And for each indicator we added, we're gonna create the weight distance sync node. When the player pawn is in range, we're going to show the indicator. And whenever the player pawn is out of range, we're gonna hide the indicator without removing it, only hiding it visually. Then I'm going to take the actor, the target actor, the cube, and for each indicator, I'm going to call hide and remove from world. Now this is convenient because when we get each indicator, it does not filter by player. So essentially, I'm just saying, okay, I don't care which player is controlling it, which player owns the indicator, remove every single indicator that this actor has, the cube. Let's open up the online multiplayer example. We're gonna open the content browser, go to plugins, world indicator system, world indicator, network example. Now, the first thing I want to mention is that we must add a network component to our player controller. We're going to open up the blueprints folder, framework, and then we have an example player controller. Let's open it up. The important part about this player controller is here on the left, where we can see that it has an indicator network component. Okay. This component is designed to be subclassed, and that's the reason why when we open up again the content folder, we can go back to the network example folder, and we're going to see that we have an example for a subclass of the world indicator network component. This logic inside the player controller is not relevant directly for world indicator. I'm just going to explain it real quick. What this does is it calls the button press function on the server only. So we're not calling this on clients. We want to call this on the server. Okay, now that we've got this out of the way, we can go ahead and open up the maps folder. And I'm going to go over the multiplayer lobby level real quick. If we want to test the multiplayer in a package build, we need to have a host computer and then another computer join the host. Okay, so once we have one computer running the host server, the other computer is going to need to get the IP address of the host. This is done through the CMD and then searching for ipconfig and then choosing the IPv4. You can search Google on how to do this. It's a bit advanced. You don't have to do that. What I'm going to do is just open up the indicator multiplayer level because I'm not going to be packaging it. And then I'm going to go here into the settings, net mode. I'm going to choose client and also 2 players. And this is how we're going to be conducting the examples. Maybe I'll switch to listen server at some point just to prove that it works. All right, let's start with a quick showcase of the examples now in network multiplayer mode. So I'm running the game in client mode. We have 2 clients. I'm going to enlarge this second client, and I'm just going to show that it works. So this is the first indicator added. Both clients can add, can remove it, and they can see it. Next, we have the adding indicators to the bones of the mannequin example. Adding an indicator at location. The example where we force the border widget and then we switch between them. And the cool thing is that this example is working per player. Compared to the other ones where if you notice, I can, when I am gonna press the button now, it's gonna disappear for both players. But this example here is per player controller, so something to keep in mind. Then we have the distance node. There it is. Each one of the players gets their own version of this on their machine. And the line trace example. Each player gets their own version again. They do not see each other's because they are on different machines, and the world indicator system is running only locally. And finally, the gameplay example, which is a bit buggy because the physics of the cube needs to be replicated, but it can still work. Again, the player that's close to the cube, their indicator disappears. When they leave the cube, it tells them, hey, come back to the objective. Yeah, it's a bit buggy this way, but we're gonna make it. And the cube goes, no, and the cube goes inside. Awesome. Then we can respawn the cube. add the indicators, remove them. These are essentially the examples, and we see that they work nicely in multiplayer. Let's go ahead and open up the blueprints and see what's going on under the hood. Let's start from the first example, a reminder. I'm going to open up two of my clients here. This example works for both clients immediately. One client clicks the button, the other client immediately sees the indicator. So we're broadcasting, adding this indicator to all clients. All right. And then we remove it for all clients. We add it for all clients, and then we remove it for all clients. Let's get into the blueprint. So I'm going to select the button, open up the blueprint of the button, and similarly to the single player examples, what happens here is the button gets pressed only on server. Then what we do is we broadcast the call to all the other instances on the clients. So we call this global function getWorldIndicatorNetworkComponent. This is important because this function is looking for the network for the indicator network component on the first player local player controller. This is similar to calling getPlayerController at index 0 and then calling getIndicatorComponent. I'm sorry, getComponent by class, and then choosing the indicator. Let's search for network for the world indicator network component. Okay, and then checking here if is valid. Okay, because we have the found and not found versions. So always remember that for the online multiplayer out-of-the-box functionality, we must have a world indicator network component on our player controller. Once the component was found, we're going to use this component and call the broadcast add indicator to all players. Okay, why all players? Because that's my decision for the example, but we have other options like add indicator, broadcast add indicator to all players. We have add indicator by actor tag, which means that the player must have an actor tag for people maybe who don't want to use gameplay tags. This is network heavy, so it's not recommended to use. Might deprecate this one in the future. Broadcast add indicator by gameplay tag. So only clients that have an ability system component that has the selected tag here will receive the indicator, or another simple one is add indicator by in range. So we can add the indicator only to clients that whose pawn is in range. All right, so we add the indicator. I selected to add unique. Do not add any indicators if they're already existing on this actor for the given player controller. And then again, when we want to remove, we again get the network component from the player controller, and we broadcast remove indicators by target actor. And the target actor is, of course, the cube. Let's check out this example where we're adding an indicator to the static world location of this smiley face instead of adding it to a replicated actor. We're going to select the button, open up its blueprint. And now I decided to do something a bit different for this kind of logic. And instead of adding specific events for adding the indicator at location, we have a generic broadcast event that is received on the clients of all the client versions of the world indicator network component. Okay, so I'm going to get into this struct in a moment and also explain how it's optimized for network replication. But let's go ahead and understand what's happening here. We're getting the world indicator network component. We check that it's found. Again, this is a component that's added to the player controller. And then we broadcast this event to all players. This is a generic event, okay? The receiving end is going to be the network component. So what we're going to do is go to World Indicator System, the plugin folder, open up the network example, and there we can find the indicator example network component. Let's open it up. Inside the World Indicator System component, we have this event, the event indicator event received. Indicator event received is designed to be overridden in subclasses. Okay, this is a subclass of the World Indicator System component and network component, I'm sorry. And this is the overridden version. What we do here is we check which gameplay tag was sent. In our case, we only have one option. I did not make more options, but this is for the example's sake to show that you can add you can go ahead and add more pins, for example, for another gameplay tag, such as health, I don't know, different gameplay tags that I created. They are pretty generic. Half opacity means I am expecting to like create an indicator and maybe set its opacity to half. Okay, it's irrelevant right now. What I was trying to explain is that we get a generic event, we switch on a gameplay tag, and then we can choose which logic we execute with this generic event based on the gameplay tags. Since the gameplay tag is at a location, we're gonna, what the network component does is it adds an indicator at the given location. And then we create an indicator reference, we store it. When the function is called a second time, we take this reference, check that it's valid, we hide and remove the indicator, and then we dereference the indicator so the system can clean it up from memory. This event is executed on all clients. Now let's look at the struct that carries all this information. Here we have the world indicator network data, net data. This struct is sent as the payload to replicate over the network. This struct is optimized in the way that when everything is left empty, nothing is essentially sent. It's really a lightweight RPC call. The indicator data asset, if it's set, it's going to be sent as a string only the first time that this function is used. The second time, it's going to be optimized. So be aware of that. Target component, the same. It's going to be sent with additional information the first time we call this function, but for the next call, it's going to be optimized. Socket name is never optimized, so it's recommended not to use it unless it's necessary. Target location is optimized as long as it's the 0 vector. When it's not the 0 vector, it's not optimized and it's not recommended to use unless it's necessary. And the optional tags can be optimized. These are gameplay tags, and this what I'm going to show is true for every broadcast function, such as add indicator all players. Here we have the optional tags. They can also be optimized. And the indicator data and target component are also optimized the same as this struct. Again, the tags can be optimized by going to Edit, Project Settings, enabling fast replication. Okay. Now, enabling this means that you must ensure that the hierarchy of gameplay tags is the same across server and clients. It's out of the scope of this tutorial, so You just should be aware of it. So the gameplay tag can be optimized. By default, it's not optimized and it's sent as a string. Now, the interesting thing to pay attention is that I'm not sending any information except the world indicator location. And essentially, this generic function gives me the freedom to override it, the event received, in the world indicator component. And then I can choose to do whatever I'd like locally, because this is called on the client side. So any of the add indicator functions from the single player example can be executed here. The variables are just useful to decide on which logic we want to execute. For example, I could have not even sent a location, given that maybe I already know which location it needs to be added, depending on the gameplay tag, for example. Again, this is just for example's sake. This can be as optimized as not sending any information to sending only gameplay tags and then choosing what to do, or sending more information, such as also a data asset and target component. Next, let's take a look at the async node distance example. Keep in mind that the async node and the indicator is created separately on each client. Each client owns their own version of the indicator, except the events for adding and removing travel across the network. All right, let's select the button and open up the blueprint. As always, first press on the button, we're adding an indicator. Second press on the button, we're removing an indicator. Let's see how the indicator is added. We get a reference for the indicator network component from the first player controller. And then we broadcast add indicator. Now, the interesting part here is since we're broadcasting this event, we don't get directly a reference for the newly created indicator. Instead, we need to take the world indicator network component and subclass it. Then we have complete freedom to choose what happens after an indicator has been added. Before we get into the optional tags here, let's see the receiving end. So the receiving end is the indicator network component on a client. So to find the indicator network component blueprint, we're going to open up world indicator, network example, and immediately we have the indicator example network component. In here, we have the event indicator added. This gets executed on clients. We get a reference to the newly created indicator, and we get optional tags, which we can use to decide which logic we want to execute. Back to the distance example. So here we create an indicator, and we send this to all players. So each client is going to create an indicator when this event is called with this kind of indicator data, with this replicated target component, which is the cube, the blue cube, and then the optional tags. I believe I can remove auto show in this case because we're going to be using the async node distance. The tag that we're sending is async node distance. Again, this is for demonstrational purposes. You can use it in your own projects, but this is for demonstration purposes. Let's go ahead and open up the receiving end again. On indicator added, event indicator added. We have an example switch on gameplay tag. So I have optional tags here, and I'm checking which tag I received. Since I received the async node distance, and we want to see what happens when we receive the tag async node distance. What I decided to do is whenever I'm given the tag async node distance, I create a world indicator distance from actor event with a radius of 600. And I'm looking at the distance from the owning pawn. I might as well call get player pawn at index 0 or whichever actor you want to measure the distance from. And whenever the player pawn is in range of the indicator, we show it. And whenever it's out of range, out of 600 centimeters, we're going to hide the indicator. Again, to go over this because it looks complicated, honestly it's not. We receive an indicator that's just been created on the client. We have the optional tags. I switch on them. This thing is a gameplay tag container, so you could do whatever you'd like with it. And I give different examples for different gameplay tags that are received on this function here, on this event. Awesome. Now, actually, you know what? Let's do a cute little test. We can go ahead and switch this tag from async no distance to a different tag. Let's try async node line trace. Okay, the async node line trace tag is going to create the line trace example for us instead. Let's go ahead and try to do that. So we've got the line trace. Okay, maybe line trace. Okay, I'm gonna send the line trace gameplay tag instead, and let's test what happens in this case. I'm gonna go ahead, press the button, and instead we get the line trace example. You see, whenever the camera does not have a clear line to the cube, we get this blocked sphere. Awesome. I hope this makes it a bit more clear. Essentially, the way this functions in every multiplayer example is we need the multiplayer component. We always call events such as add indicator, or we can even call the broadcast world indicator event, the generic event. And then again, we have the payload, which has optional tags and other information. And then we need to subclass the world indicator network component. Okay, and then we decide what happens when an indicator is added, and we decide what happens when an indicator event is received. Okay, removing the indicator is much more simple. We're gonna get the network component, and since we want to remove it for all players, for all clients, we just simply remove, we broadcast remove indicators for this target actor on all clients. Actually, but not least, we have the gameplay example. This example is just a little bit heavier on the multiplayer knowledge side, so be aware of that. Again, what happens is that we're spawning a cube. This cube is replicated, and then we're adding indicators for the cube and for this goal here. The indicators are, again, world indicator is a local system, so they are all replicated and created locally on each machine. And the gameplay logic itself is of course running on the server. So here we're going to push the cube into the goal somehow, and the mission is successful. And then we can respawn it and add an indicator, remove an indicator. Let's go ahead and check out the blueprint. We're going to select the button, open up its blueprint. And there are a few interesting things that are happening. Go ahead and check out the single player example for this first, because I'm not going to go too deep into the logic, but I'm going to explain what happens here multiplayer wise. So here, when the cube is spawned, it's only spawned on the server. And then the cube reference is replicated with a notify. Okay, this requires just a bit of multiplayer knowledge. Since the cube is replicated, we get this rep notify that the target actor has been created. And essentially, we do not need to call the functions over the network. So because this is replicated, we are on a client, and we can just go ahead and add the indicators for it normally, just like the single player example. Okay, so once the cube has been replicated, we just, to make sure, check that the cube, the target actor is the cube, that it's valid locally on the client, and then we add the indicator for this client. and then we add the distance async node, which again, go to the single player example I'll explain what happens here. And then we add an indicator for the goal. The difference from the single player example is probably mostly here on end mission and mission success. So when the mission success occurs, we broadcast removal of indicators, because once the mission has been successed, we just want to remove the indicators for all clients. So we take the indicator component from the first player controller and then broadcast the remove indicators for the target. So we remove the indicators for the cube and we remove the indicators for the goal. If the mission has been restarted, we're gonna go ahead and destroy the cube. This needs to happen on the server. We're gonna set with a rep notify the reference to, okay, sorry about that. So we actually set the reference to null, therefore we must check for validity here, because sometimes we set it for null and then this does not need to execute. This is a bit more complicated because we're doing spawning here, and spawning is on the server, needs to be replicated. Okay, and then we take the network component and then we broadcast removing only from the goal. It's enough for us to destroy the cube. Once the cube has been destroyed, the world indicator system will automatically remove its indicator. So again, this also will be handled in a multiplayer environment, in an online multiplayer environment, because the destruction needs to happen on the server and then it should be forwarded down to the clients. And the clients, once the actor is destroyed, also the indicators are going to be taken care of on the clients. All right, this about sums it up for all the examples. I hope you found this video informative, and feel free to join the Discord, ask any questions, and that's it. Happy deving.